All right, last section from this unit. This is going to be the first section that we apply factoring. Okay, so we spent the first 80% of this chapter learning or reminding ourselves to factor. And then section 5.5 is our first opportunity to apply factoring. We're gonna learn or remind ourselves of solving a new type of equation. Up till this point in this class, we've only solved the linear equations. So here's what I want to ask you. Okay, I'm going to skip to the second line. If I give you this, if I tell you that A times B is 0, so we're just thinking arithmetic. So if we're playing a little puzzle and I say, okay, two numbers being multiplied together, A times B is equal to 0. What can you say without hesitation about one of those numbers? It has to be 0, because the only way to get 0 is to multiply by 0. So this second line says, if A times B is 0, then either A is equal to 0 or B is equal to 0. That has to be true. Our book calls this the zero factor property. I just call this the principle of common sense. Okay, I think we could, if I asked everyone individually that, you would know. The first sentence just says it another way. If two numbers have a product of 0, then at least one of the numbers must be 0. Okay, so that's the principle of zero products, or the zero product property. And this allows us to solve a new type of equation using factoring. And so what we're going to do as we slide down the page here a little bit is I'm going to do example 1. Example 1 is just a very straightforward application of the zero factor property. Notice in example 1, I have two things multiplied together. I've got 3x minus 4 times x plus 8. And what I tell you is when I multiply these two things together, I get 0. So I'm just going to apply what you told me, the trivia you just told me a minute ago, is I know this. Since I don't know what the values are, I do know that when I multiply this first value times this second value and I get 0, then at least one of those things has to be 0. So what I can say is 3x minus 4 has to equal 0, or x plus 8 has to equal 0. Okay, that's just applying the zero product property. The key here is it has to equal 0. Okay, we'll get to some problems in a little while, and sometimes students forget that it has to equal 0 in their excitement to solve the problem. From here, these should be nice and relaxed equations to solve. The 3x minus 4 equals 0. I'm going to add 4 to both sides, and I get 3x equals 4. Then I divide by 3, and I get the first solution is x equals 4/3. The second equation, I subtract 8 from both sides, and I get x equals -8. Those are the two possible values that will make this true. When I plug either of these in, I will get something times 0. So when I plug -8 in, just as an example, what's 3 times -8? -24. And -24 minus 4, that's -28 times, what's -8 plus 8? 0. There it is. That's the zero factor property. -28 times 0 is 0. And the same thing would happen with 4/3. So I'm going to write my solution as a solution set. Since I've got 2, I've got -8, I've got 4/3. You don't have to put it in number order, but that's just math people like to be proper like that and put it in number order. And there's my solution set. So I'm going to give you 30 seconds. Do the same thing for exercise 1. You're just straight applying the zero factor property to solve that equation. So once again, I've set this up. I've got a product of two numbers, but I don't know either of those numbers. I know an expression for each of the numbers. One of them's x minus 5. One of them's 4x plus 7. But what I do know is when I multiply them, I get 0. So according to this common sense principle, each of these has the opportunity to be 0. If x minus 5 is 0, then the value that works there would be x is 5. Over here, when I solve this one, I'm going to get that x is equal to negative 7 over 4. You can check that. It's easy enough to plug those values in and determine that they give you 0. So my solution set in this case, just going to write it right here, is negative 7 over 4 and 5. Those are the two solutions. Let me just give you a notational help, okay? Because remember, I'm trying to help get you ready for college algebra, where notation's super important. You're not using parentheses here. Parentheses are used for intervals, okay? You are using braces. Braces are for sets, okay? So if you write this down, if you write negative 7/4 and 5 like this, whoops, and you use parentheses, that's not right. You're communicating something completely different to me, okay? So that would be wrong. All right, well, where that takes us is here. What we've just spent a few sections doing is factoring. Factoring, okay, just writing this down so it's in your notes and you can know why we're here. Factoring is the process of writing an expression as a product. So I'm going to combine my newfound ability to factor with this zero factor property to solve these equations. Now we'll talk much more about these equations. It's the very last section of this class. But what it's called when you have a degree 2 equation, when you have a squared, this is called a quadratic equation. And we'll talk a lot more about solving those, as I said, later in the class. We'll be able to solve quadratic equations that can't be factored, but for now, we're only going to be solving those that can. So here's the process. Again, I am 97% sure all of you have seen this at some point. I'm probably just reminding you of this, and those neurons are firing. Hopefully, you're remembering. If not, then this is exactly what you do. I'm going to take this trinomial over here. It has to be equal to 0. This is important. And I'm going to factor the trinomial on the left. So this is a trinomial. We've got a 1 in front of the x squared, so I'm just going to unfoil it. So here we go. So unfoiling, it's equal to 0. X squared is x times x. My signs, since this is a negative 24, my signs are +1 minus the other. And then the two factors of 24 that are 5 apart are 8 and 3. So it's going to be +8, -3, because they have to add up to a +5. And now what I have is just what we did in the previous two examples. I have got the product of two numbers. I do not know either of them, but what I do know is when I multiply them, I get 0. And so then I can go ahead and do this step. I could say, okay, the x plus 8's got to be 0, or the x minus 3's got to be 0. On this first one, when I subtract 8, I get the answer x is -8. On the second one, when I add 3, I get the answer x is 3. There's my two solutions. Again, just sticking with the theme, you have every ability to know you got the problem right when you leave. You can take both these numbers, you can plug them back in the original quadratic and confirm that you get 0. Just for time's sake, I'm not going to do that. If we have time at the end, we can check a couple just to be sure. But here's my solution set, -8 and 3. All right, exercise 2, right to the right of that one is yours. Have fun. All right, so I'm hoping that this factoring right here is not too challenging. I'm trying to keep most of the factoring on this lesson should be nice and straightforward because we're learning something new here. So x squared minus x minus 6 is equal to 0. That's in the right form. That's good. Since my leading coefficient is a 1, I'm just going to unfoil this. So here we go. We're unfoiling. X squared is x and x. My signs, since this is a -6, I'm hoping that you wrote down a plus and a minus or a minus and a plus. The order is unimportant. And then the two factors of 6 that are 1 apart are 2 and 3. And which one gets to be the -1? What'd you say? It's going to be 3 because they have to add up to a negative. Okay, so the -1 wins in this case. So the 3 is going to be the one that wins. So that's why I chose the 3 to be the -1. All right, now I have the product. I'm multiplying two unknown numbers together. I get 0. So that means either the first unknown number, the x plus 2, has to be 0, or the second unknown number, the x minus 3, has to equal 0. In the case of the first one, when I subtract 2 from both sides, I get x is -2. Case of the second one, when I add 3, I get x is 3. Again, we can come back and check a little later if time allows, but for now, my solution set is -2 and 3. If you got a question, a comment, or a concern, please be sure to ask. If not, go on to exercise 3. We're just going to practice this for the rest of our class time together today. Again, the first thing that's super important here is that this is equal to 0. So it's in the right form. So the left side of this is x squared minus 49. It's a pretty straightforward difference of two squares. So I'm going to factor it. X squared, x and x. My two factors of 49 are 7 and 7. Plus 1 minus the other, or minus and plus, doesn't matter. So once again, because we factored, I have the product of two numbers that I don't know either of them, but I do know when I multiply them, I get 0. So that means, according to the 0 factor property or common sense, I could take each of these factors and set them equal to 0. The first one, when I subtract 7, I get -7. The second one, when I add it, I get +7. Again, we'll check that later. And my solution set is -7 and 7. If you got a question, ask it. If not, exercise 4, we're going to do that. I'm going to ask you one clarifying question before I set you free to do it. What is the thing that I have to resolve before I can solve this equation? Yeah, that 10x, we have to have it equal to 0. So you got to put that 10x on the other side. So subtract the 10x, just like you said, that was great. Put it in the proper place. Okay, notice all of my polynomials are always in descending order. And then factor. Okay, should work out real nice for you. So just to give everybody a nudge in the right direction, keep working. I'm going to give you another 30 seconds or so, but I am going to do this first step in case anybody's struggling. I'm going to subtract that 10x because it is super important that my equation is equal to 0. It's the only way we can do this. And then what I meant by put the 10x in the right place, in case you didn't understand that, is I've got my x squared term, that's going to come first. And descending order just means you keep going down the powers of x. So that means the negative 10x is going to go in the middle if I go descending order, and then the plus 21. And then that equals, since I subtracted the 10x from both sides, that equals 0. I'll give you a little more time in case that was helpful to get caught up, and then we'll finish this problem off. Once again, there's a 1 in front of the x squared, so I'm going to unfoil this. X squared is x and x. This time, because the 21 is positive, my signs have to be the same. And so the negative 10 tells me they're both going to be negatives. And the two factors of 21 that add up to 10 are 7 and 3 or 3 and 7. The order does not matter there. Again, I've got two unknown numbers that I multiply to get 0. So that means either the first one equals 0 or the second one equals 0. If x minus 7 is 0, when I add the 7 to both sides, I get 7. If x minus 3 is 0, when I add the 3 to both sides, I get 3. So my solution set is the set with 3 and 7 in it. All right, I have a purpose in mind with the next problem. So if you don't get this one quite right the first time, there'll be another one like it on the second page. Okay, but go ahead, exercise 5, factor that and determine what the solutions are going to be, please. All right, so on this one, this is not a trinomial. Okay, so I'm just going to talk you through a couple of the mistakes students sometimes make, and I just want to tell you why that's not the right thing to do. I know we got an x squared there, and so students automatically try to unfoil this. But this is not a trinomial. There's only two terms. So remember, don't forego the factoring strategy we just talked about a few minutes ago. First thing I'm going to do is I'm going to look for a common factor, which there is. These two terms share something in common. What do they both have in common? 3x. And when I factor out the 3x out of the 3x squared, I'm left with x. And when I factor out the 3x out of the 12x, I have plus 4. So there's my two factors. Okay, I've got a common factor and then I've got a binomial. Don't change the process. Okay, I know this one looks a little different and maybe you got to this point and I didn't know what to do. That is okay. That's why this problem's on the sheet. Okay, so then what you do is you say, okay, well, I've got this first unknown number, 3x, times this unknown number, x plus 4, equals 0. So I'm going to do the same thing I did. So that means either the first unknown number, 3x, has to be equal to 0, or the second unknown number has to equal 0. So on this first one, if I divide by 3, well, that means x is 0. Okay, that's a legitimate solution. Don't be scared. And on the second one, if I subtract 4 from both sides, then I get x is negative 4. There's my two solutions. So here we go, 0 and negative 4. Oop, that's not numerical order, but I told you that doesn't really matter, just proper. So I'm not using good grammar if this was an English class. If you got a question about that, okay, sometimes that's a tricky one. Ask it. If not, do exercise 6. Now, exercise 6 is a contrast to that one. I have a reason for exercise 6. So give it your best try. We'll compare notes here in about 75 seconds. Once again, is there a common factor to these terms on the left? What is it? 3. Thank you for your help. Appreciate that. So I'm going to factor out that 3. When I factor out the 3 out of the 3x squared, I'm left with x squared. Factor out the 3 out of 21x, I have 7x. Factor out the 3 out of 36, I have 12. As always, this 3 is part of my problem, so I'm going to write it down. There is a 1 in front of the x squared here, so I'm just going to unfoil this. X squared is x times x. My signs are going to be the same because the 12 is positive. Since I want things to add up to a positive 7, they're both going to be pluses. And the two factors of 12 that add up to 7 are 4 and 3, or 3 and 4. Now, notice the contrast here. The reason I put these two problems side by side. So I want to help you avoid an error. My first factor, this 3, is there a variable associated with that 3? No. Okay, so I'm just going to make a little note for you because I don't want anybody to leave here confused. Okay, on that 3, there is no variable. So that's just the number 3. Can 3 ever be equal to 0? No, 3 is 3. 0, 0, they are completely different numbers. So 3 cannot equal 0. Before I go on to the factors that can be 0, do you see the difference between this factor 3 and why over here, when I had 3x, I could set that equal to 0? Do you see the difference between those two things? This one here has an x associated with it. There's a variable, an unknown. So it could be equal to 0 under a certain condition. This factor right here is just 3. There's no variable. It can never be 0 under any conditions. So I'm done with that. I'm done with the 3. It does not affect my solution to the equation at all. Okay, so all that matters now is x plus 4 equals 0 or x plus 3 equals 0. So in this case, when I subtract 4 from both sides, I get the first solution is negative 4. The second one, when I subtract 3 from both sides, I get the solution negative 3. And that's my solution set right there, negative 4 and negative 3. Does that seem reasonable? I don't want you conflating those two things. I know they look very similar, but that x makes all the difference. Okay, let's flip the page. We got just a few more problems. We got plenty of time. We're doing really good. Exercise 7 is just another example of it's supposed to be another example of a common factor. I'm noticing a typo, so I'll have to fix this sheet before and repost it. There should be an X on the end of that 50 right there. So if you were working ahead, haha, that'll teach you to work ahead. Herkster's always got a typo in there because I got large fingers and they don't always work. Yes, question. Oh, okay. All right, so this problem has a common factor when we fixed my typo of X. Okay, so I'm going to factor that X out. And then what's left from my other terms is X cubed. I factored out an X, I have X squared. 5X squared, I factored out an X, I have 5X. And then negative 50X, when I factor out the X, is negative 50. We good so far? All right, before I worry about solving the equation, I've got that trinomial. There is a 1 in front of the X squared, so I'm going to unfoil this. So X squared is X and X. My signs, since it's a negative 50, are going to be different, so plus and minus. And then the two factors of 50 that are 5 apart are 10 and 5. Because they should add up to a positive, the positive wins. It's going to be a plus 10 and a negative 5. I gave this problem for 2 reasons. The first reason is I just wanted to practice again when you factor out a common variable to make sure you included that. And then the second reason is I just wanted you to see that you can get equations that we factor that have more than 2 solutions. Okay, so that's what's going on here. So I've got 3 solutions. The zero product property, or the zero factor property, our book calls it, applies just as equally here. So either X is 0, because that's my first factor, or X plus 10 equals 0, or X minus 5 equals 0. The first one, no more solvings required, it's set. The next one, if I subtract 10, I get negative 10. And the third one, if I add 5, I get X is 5. So my solution set this time has 3 elements. That's no problem. Negative 10, 0, and 5. Again, if there's a question, ask it. We've got 4 more. You've got a test on Thursday. I'll be in my office before the test. Do exercise 8. It's the first one that we're doing that has another number other than 1 in front of the X squared. So factor it, set your factors equal to 0. Right, so just to remind you, we're going to factor this trinomial on the left using the grouping method, or you used some other method, that's fine too. So I'm going to multiply the 2 times the 5 here on the outsides, and 2 times 5 is 10. It's a positive 10, so my signs are going to be the same. Need to add up to a negative 11, so that means they're both going to be negative. And the two factors of this 10 that add up to the middle term of 11 are 10 and 1. So 10 and 1 or 1 and 10, the order does not matter. I've said that a bunch of times. I'm going to use this negative 10 and negative 1 to separate this middle term and create a 4-term polynomial. So I'm going to have 2x squared and then minus 10x minus 1x plus 5 equals 0. This is the grouping step. So I'm going to group the first 2 terms. I'm going to group the last 2 terms. First 2 terms have something in common. That's why we picked those particular factors. So out of 2x squared and 10x, I can factor out a 2x. 2x squared, when I factor out the 2x, leaves me x. Negative 10x, when I factor out the 2x, leaves me negative 5. Now, again, I have a lot of purpose with these problems. I'm trying to help you review for the test. One of the things when we talked about factoring by grouping was having an awareness of the signs. Notice I have a positive x and a negative 5. In the next 2 terms that I've grouped, I've got a negative x and a positive 5. The signs are exactly opposite. So that is my clue that I'm going to factor out a negative out of this. And when I do that, negative x, I factor out the negative, I have x. Positive 5, factor out the negative, that's negative 5. My grouping worked. I've got the exact same thing in the parentheses right there. So I'm going to factor it out, x minus 5. And then we have 2x minus 1 left over. So I didn't quite leave myself enough room on this, so I'm sorry that we're going to get a little scrunched here. I've got my 2 unknown numbers equal to 0. So I've got x minus 5 equals 0 and 2x minus 1 equals 0. The x minus 5, when I add 5 over to the other side, I get x equals 5. I'm going to write that right here. The 2x minus 1, I'm first going to add the 1 to both sides and get 2x equals 1. And then I'm going to divide both sides by 2, and I get x is 1/2. And there's my 2 solutions. The first one is 1/2, the second one is 5, and I'm done with that problem. All right, so if you would, exercise 9 is essentially the same thing. It's just more practice. We've got the time, we need the practice, so go for it, and we'll compare notes in a minute or 2. Bless you. I'm just going to get started with the busy work. You keep working. Okay, I'm not trying to rush you, but I'm going to do the AC. I'm going to pick my factors. So check your work with my work, what you got so far. So the 6 times the -7 is -42. So first off, that tells me my signs have to be negative and positive or positive and negative. The order does not matter. And then the two factors of 42 that are going to be 19 apart. Again, use your calculator. You can fiddle around with the factors. You know, 7 times 6, 14 times 3. And then the ones that are going to work here are going to be 21 and 2. I made the 21 negative because they have to add up to a -19. So I've got 6x squared minus 21x plus 2x minus 7. The grouping step, I can take a 3x out of the first two. 6x squared, I factor out 3x, leaves 2x. -21x, factor out 3x, that's -7. Now, the second pair of terms, we encountered this situation a few days ago. The second pair of terms have nothing in common, but I do notice this second pair of terms is the same thing I already have in parentheses. So that tells me that I'm just going to group them. There's nothing really to do. The grouping worked. I've got 2x minus 7 in both parentheses, so that's great. I'm left with a 3x from the first and then a +1 from the second. There's my two factors. They're being multiplied to equal 0. So I'm going to take each individual factor. 2x minus 7 equals 0. 3x plus 1 equals 0. Again, I could use a little more room. I apologize for my lack of forethought there. Maybe you write smaller than me, so you're not having a problem. So the first one, I'm going to add 7 to both sides, and I get 2x equals 7. I'll divide by 2, and x is 7/2. There's my first answer. The second one, I'll subtract 1 from both sides, so I get 3x is -1. And when I divide by 3, I get x is -1/3. So my solution set, which I'll write right here, is -1/3 and then 7/2. Those are the two answers. All right, we got 2 more problems. We're approaching the finish line. Okay, so the next problem right here, exercise 10. Just wanted to give you this one because it starts off a little bit of a mess. You see it's already factored, so you get your hopes up like, woohoo, not much work. But then you see it's equal to -21, which is bad. Okay, it has to equal 0. So before we do anything, talk me through what we need to do. We need to do 2 things before I can solve the equation. What's one of those things? I got to refoil it. Yeah, that's a great idea. So refoil these 2 things. And once you've refoiled these 2 things, what's the second thing that you need to do? You got to add the 21. Then you can solve. So go for that. See how you do. I think you're going to do great. Right, so I refoiled the left while you were working. First, outers, inners last. So when I multiply my first, x times x gave me x squared. My outers, x times -2 is -2x. The inners, 8 times x is 8x. And then lasts, 8 times -2 is -16. Then the second thing you told me to do was I got to get this -21 over to the other side. So I add it to both sides. And when I combine my like terms, I got x squared, -2x plus 8x is 6x. -16 plus 21 is 5. It's now equal to 0. Again, this factoring I don't think is going to cause you too much trauma. I'm going to unfoil this. There's a 1 in front of the x squared. X squared is x and x. My signs are going to both be the same. That's what the positive in front of the 5 tells me. And they're both going to be positive. That's what the positive in front of the 6 tells me. And then the two factors of 5 that add up to 6, well, they're the only factors of 5. So I hope they add up to 6, 1 and 5. There's my two unknown numbers. I'm now going to say, okay, at least one of these factors has to equal 0. I'll subtract 1 on this one. The first solution is -1. I'll subtract 5 on this one. The second one is -5. There's my solution set, -5 and -1. One more problem, just so that we feel good about the day. Exercise 11 is basically the same thing, just with some extra terms. So give it a try. I'm going to, just for time's sake, I'm going to give you 2.5 minutes to work as much of exercise 11 as you can, and then we'll finish up. All right, just for time's sake, I'm sorry if you're still working, but I like to let you out on time, as you know. So I'm going to get started. I'm going to FOIL on the left. First, 2x times x is 2x squared. The outers, 2x times 5 is 10x. The inners, 1 times x is 1x. And then the last, 1 times 5 is 5. On the other side, x times x is x squared. X times 3 is 3x. 11 times x is 11x. And then my lasts give me plus 33. Okay, so that's a big mess. Let me collect those like terms, make it a little less of a mess. So I got 2x squared, 10x and 1x is 11, plus 5. On the other side, I've got x squared, 3 and 11 is 14, and then plus 33. So just like the last problem, I have to have this equal to 0. Okay, no choice. So I'm going to take everything, I'm going to move it over onto the left. So that means I'm going to subtract this x squared from both sides. And when I do that, I have 2x squared minus x squared is 1x squared. I'm going to subtract the 14x from both sides. 11x minus 14x is negative 3x. Okay, so we're gradually getting rid of everything on the right. And then lastly, I'm going to subtract 33. And 5 minus 33 is negative 28. I've gotten rid of everything on the right, so now it's equal to 0. That's the format I have to have it. No choice in that matter. And as I said earlier, the factoring here, I don't think this is too bad. It's not the worst factoring we've had on this section. X squared is x and x. The negative 28 tells me my signs are different, so plus 1 minus the other. The factors of 28 that are 3 apart are going to be 7 and 3. I've made the 7 negative because they have to add up to negative 3. 7 and 4. 7 and 4. That's what I said. I don't know what you heard, but that's what I said. 7 and 4. Thank you for your help, keeping me honest. So now I'll take x plus 4, okay, which I was reliably informed is what I meant to say. And then x minus 7, those are my two factors. I'll subtract the 4 on this one. I get x is negative 4. I'll add the 7 on this one. X is 7. And there's my solution set, negative 4 and 7.